Yes, welcome to Vision Plus and welcome back to the S.4 Mathematics. We are looking at application to kinematics and at differentiation. And precisely, we are looking at calculation of velocity and acceleration. Example 2, part A says a particle moves such that its displacement s meters is given by s equals to t cubed plus 3t squared plus 5. Okay, this is the expression for the displacement of this particle at any time t. Now, it is the question to guide us on what to do. Part 1 says, calculate the displacement when the time is t seconds. So, Roman 1 says, displacement. Now, we have here the expression for displacement at any time t. At any time t, the particle will be this displacement away from the origin. Now, what can we do here? Now, the displacement when t is 3 seconds simply means we just need to substitute for the time 3 seconds in the expression for displacement. Therefore, our displacement s becomes t. T is now 3 seconds. 3 cube plus 3, our t is still 3 squared plus 5. Okay, now we want to get how far the particle has moved after 3 seconds from the beginning. Anyway, we press the calculator and simplify that. 3 power 3, 3 power 3 is 27. Also, this is 27. 3 times 3 squared. 3 squared times 3 plus 27 plus 5, 59 meters. So, when the time is 3 seconds from the beginning, okay, the particle will be 59 meters away from the initial position where it started to move. So this is the answer for Roman 1. Going to Roman 2. Roman 2 says, calculate the displacement between the 4th and the 10th second. We need to get the displacement between the 4th and the 10th second. In other words, we are saying if the particle has moved from the beginning, this is our origin, up to some point 4 seconds, and then it continues moving, until we have here like the 10 seconds. Now, what distance or displacement has it had between the 4th second and the 10th second? Now, what can we do? We need to get the displacement from the origin up to the 10th second. We also get the displacement from the origin up to the 4th second, and then we get the difference. This is now the difference of the displacement of the 10th second minus the displacement of the 4th second. That is what we can do. We get the displacement at time 10 seconds. Then we get the displacement after 4 seconds. And then we get the difference in the two displacements. It is the same. We first get the displacement after 4 seconds from the beginning. We also get the displacement after 10 seconds from the beginning. And then you get the difference in the two displacements. So, in Roman 2, we shall say displacement displacement when t equals to 4 seconds. Let's first get the displacement when the time is 4 seconds from the beginning. That means our displacement s becomes, substitute for t as 4 in the expression for displacement at any time t. That means we have 4 power 3 plus 3. Our t is 4 squared plus 5. Just substitute for t as 4 wherever you find t. Then you simplify this. 4 power 3 plus 3 times 4 squared plus 5. I'm getting 117 meters. This means that after 4 seconds from the starting point, the particle had moved a distance of 117 meters, or a displacement of 117 meters. Now, let us also get the distance from the origin that the particle moves after 10 seconds. That means we also come and say displacement when t equals to 10 seconds. We need to get the displacement at the 10 second. So we shall say displacement at the 10 second. We come and use the same expression for displacement at any time t, which is t. Our t now is 10 power 3 plus 3. Our t is still 10 squared plus 5. Then you simplify. You press the calculator. 10 power 3 plus 3 times 10 squared plus 5. I'm getting 1305 meters. So after 10 seconds from the beginning, the particle will be 1305 meters away from the beginning, or from the initial position. Now, if after 4 seconds the particle is at this distance, after 10 seconds it goes in front at this distance. Now, what is the distance between the 2 seconds? That is when the time is 4 and when the time is 10 seconds. So we say now, therefore, displacement between, let me use this, 4 and 10 seconds, it now becomes, okay, the displacement at 10 seconds minus the displacement at 4 seconds. We simply subtract the two distances. That is 1305 minus 117 minus 117. Yes, I'm getting 1188 meters. So the distance between the time 10 seconds and 4 seconds that the particle moves is 1188 meters, and that is the answer. Now, someone there might be thinking that, what if I get the difference in time, okay, the change in time, such that I say 10 seconds minus 4 seconds, it gives me 6 seconds. Then I use the 6 seconds substituted here to get the displacement. That will not be correct. Why? This is a non-uniform motion, okay? The speed keeps on increasing, okay? When the car starts off, for example, and then it is being accelerated, that means the speed is increasing. So it will move slowly. At first it will move slowly, and then it goes up. So when you get the difference in time, and then you want to get the displacement, this one will give you the displacement when the time is 6 seconds, okay? But it will give you displacement when the time is 6 seconds from the origin, but it cannot give you the distance traveled between the 4th and 10 seconds. Why? Because This is a non-uniform motion. The speed keeps on increasing. Take note of that. So always just get the displacement at this time, get it at that time, and you find the answer. Okay? Even when it is a uniform motion, and you first get the displacement at this time, get the displacement at that time, then you get the difference, you get the same answer. So always use this method. Whether the motion is uniform or non-uniform, this method where you find the displacement of the two given times is very correct. So that is the solution to part to Roman 2. Going to